All right, in this video, let's review spatial products or multiplication of polynomials. All right, so spatial products, for your method, difference of squares, perfect square binomial are considered as spatial products. Spatial products are designed for students to just take a look at the problem and actually do it in their head. So let me start out with for your method. As you can recall, FOIA method stands for first, outer, inner, and last. Okay, so when we're multiplying using FOIA method, this method is designed for us to have a two term times two terms. Okay, specifically, is designed for the two term in the parenthesis is kind of like like terms, just like the 2x is like term with the 3x, positive 3 is like term with the negative 4. Okay, so for example, if I have maybe like a 2x squared plus 3 times 3x minus 4, even though this is two term times two term, most of us think about FOIA method, but this is really not the type of FOIA method that we are thinking of, because this is actually technically not really two term times two terms, because in a polynomial, if the highest exponent is 2, then the next term should have an exponent 1. So what I'm having here is called the missing term. So I'm missing a positive 0x. So this problem can actually be rewritten as 2x squared plus 0x plus 3 times 3x minus 4. So now the problem actually becomes multiplying of polynomials. So FOIA method is really designed for the two terms inside the parenthesis, okay, are kind of like terms per se. All right. So when you see a problem look like this, where, okay, I got same kind of term at the front, same kind of term on the back, I can always use the FOIA method. So the first thing I do is 2x times 3x, as you can recall, which is 6x. It's going to be 6x squared, right? X times x is x squared. Then we say the outer is 2x times negative 4, which is negative ax. Positive 3 times 3x is positive 9x. And then positive 3 times negative 4 is negative 12. So the four terms I have here, the two terms in the middle are like terms. So we can combine them and say the answer is 6x squared plus x minus 12. So the answer that you end up with here is actually what I normally call a true trinomial. A true trinomial is the last three terms of a polynomial where the exponent got to say 2, 1, 0 power. All right. So when the problem like this that creates that actually leads to a trinomial answer, then when we do FOIA method, we can actually always predict what the answer is going to look like. So we can quickly just do this problem by looking at it. So let's go back to the answer. The middle term of my trinomial answer actually come from the inner and the outer combined. All right. Combined. So that means my negative ax here was the outer, my 9x was the inner. So if you know the middle term of an answer is always inner and outer combined, then we can actually do this problem, do the same problem just simply by looking at them. And the way we do it by looking at it is to say, well, the first thing I do in the FOIA method is take 2x times, let me do a magic marker, take 2x times 3x, and that will give me 6x squared. The last thing I do in my trinomial is positive 3 times negative 4, which will give me negative 12. So the middle term of my trinomial, okay, the middle term of my trinomial is going to come from the inner and the outer combined. So the outer is negative 8, inner is positive 9. So 9 minus 8 give me a positive x in the middle. So being a spatial product is designed to be done just simply by looking at it. Okay, so the quicker students can actually do this just by looking at it, the easier the arithmetic is going to be in this class. Okay, there is nothing wrong with writing everything out. It just when a problem gets real big and you have to write out so many terms, students tend to make more mistakes. All right, so give it a try. Give it a try. Practicing using FOIL methods. Okay, just simply by looking at it and write down the answer. Another important spatial product is called the difference of squares. Difference of square always has this pattern. Okay, two terms times two terms, but what's the same? But the first term in the two parentheses are exactly the same. The second term in the two parentheses are exactly the same. One sign is positive, one sign is negative. So when you see that, then you will need to recognize that this is a difference of squares. Now, I'm not saying you cannot do the FOIL method. What we're saying here is it's easier to recognize what type of problem they are so you can quickly write down the answer. So this answer is actually a trinomial answer without the middle term because the inner and the outer combined actually cancel each other out. Okay, so the first term are exactly the same, second term are exactly the same. By one being positive and the other one being negative, the both inner and the outer term are exactly the same with opposite signs, so they will actually cancel it out. If you try to follow it out, you will notice a two middle term will cancel out. All right, that's why my answer only have two terms called the difference, means subtraction, difference of squares. So 2a minus 3 times 2a plus 3 down here. The first term are exactly the same. Second term are exactly the same in the parentheses. So we recognize that this is a difference of square. So my A is 2a. My B is 3. Okay. The answer always need to have a subtraction sign in the middle or opposite sign, right? A squared negative B squared is opposite sign. So I can simply just say, okay, my A whole thing squared is going to be 4a squared minus my B is 3 squared, it's going to be 9, right? A squared minus B squared. So my answer would just be 4a squared minus 9. That's all it is. All right. So if I will pretend to put the two example I have together, let's use the same variable. Okay, I'm going to turn these A into a X. So if I have a problem that's 2x plus 3 times 3x minus 4 minus 2a minus 3 times 2a, excuse me, not a, I just say change it to x. And 2x plus 3. So if I have a long problem like this, it will be great if we can recognize that the subtraction sign outside the parentheses separate between two terms. So this is my first term, which is 2 term times 2 terms. So I'm thinking about FOIL methods. And my second term is negative 1 times 2x minus 3 times 2x plus 3. So in that case, I can quickly recognize that, okay, first term is FOIL method. So without writing so many terms on the next line, I can say 2x times 3x. The first thing I do is going to be 6x squared. The last thing I do is positive 3 times negative 4 is negative 12. My inner and the outer combined, negative 8x plus 9x is going to be give me positive 1x, right? Negative 8 plus 9. Then over here in the second term, I can quickly say, all right, what's inside the two parentheses are difference of square. So my a squared, which is my 2x squared, will be 4x squared. And my b squared is going to be 9. It's going to be 9. Difference of square always got a subtraction sign right here. So the two parentheses multiply together, give me 4x squared minus 9. But on the outside of it, there's a negative 1 going to do a distribution. So once it do that, then my second term will come out to be negative 4x squared plus 9. So that kind of eliminate a lot of extra steps, because if you will fold this whole thing out and begin to combine like terms, you will eventually will come up with the same answer. It just takes a lot extra writing. Okay, so it's just good to do these type of problem using the spatial product, or do it simply by looking at them. All right, so that's just an example of why I always ask students to do the spatial product by looking at them. Now, another good one here for the special product is called the perfect square binomial. Okay, some people call it the perfect square trinomial and such. Basically, what we have here is a plus b whole thing squared. So this right now has two terms, okay, whole thing being squared. So if you compare this problem with the power rule from the previous video, which is only have a times b, let's say there's a square right here, okay, this two problem is very different because one problem got two term in the parenthesis. The other one only got one term in the parenthesis. So if I only got one term in the parenthesis, whole thing squared, I can apply the power rule and say that's a squared times b squared. But since I got two terms in the parenthesis, I cannot say this is going to be a squared plus b squared. Okay, so because if I was say a squared plus b squared, that means I'm looking at this problem just like a power rule problem, but they are not the same thing because one has two terms, one only got one term. Okay, so I'm keep on saying in the review series here, two-term problem got to be done differently than the one-term problem. All right, so what do? Well, a lot of students will simply say a plus b whole thing squared. If I look at the square on the outside, that means my base is a plus b need to times itself two times. Since this is two terms in the parenthesis, I put them, since I got two terms in the parenthesis, when I write it out as two separately, then I will still got to put them inside the parenthesis to indicate is two term times two terms. So if you ever fold this out, what you're going to notice here, the difference between perfect square binomial and the difference of square is the signs, okay, are different. Difference of square has two different signs in the parenthesis. Perfect square binomial, you have the same sign. So when the first term are the same in the two parentheses, second term are the same in the second term are the same in the parentheses. If the two signs are the same, then this becomes a perfect square binomial problem. So every time you fold it out, you will always recognize the pattern of the answer is going to be a squared, your a squared, plus 2 times your a times your b, plus your b whole thing squared. Because the middle term of your trinomial answer here representing that when you fold it out, your inner and your outer are exactly the same. Both are a times b is ab, b times a is another positive ab. So you got two of the same middle terms. Okay, so it's good to actually memorize the formula here. So every time when you see a perfect square binomial problem, you can just simply write down the answers. So for my problem here, all right, 5t minus 3z. My a is 5t, my b is 3z. The sign will always be the way they are. So subtraction sign start out with the first term, the first sign here after the first term is always going to be minus. The last sign is always positive. So if I take my a, which is 5t, whole thing squared, I get 25t squared, minus 2 times my a, because the 2 representing 2 of the same middle term. So 2 times my 5t times my 3z. 2 times 5 is 10. 10 times 3 is 30. Okay, t times z is tz, right? 2 times 5t is 10t. 10t times 3z is 30tz. And the next sign is positive. All right, my b is 3z, whole thing squared. So 3 squared, z squared, that'll be 9z squared. Okay, so now there's nothing wrong with actually write it out this way, then perform a, minus again, and actually write out the forward method. Okay, now if you can write out like this and do forward method in your, just by looking at it and write down the answer, we get the same thing. All right, but it just sometimes makes it easier to just know the formula and know what the answers are just by write out like the formula says. All right. The last thing I'm going to go over quickly with you is multiplying polynomials. We do this from time to time in this course. So let me do a quick review. So multiplying polynomial is basically like a distribution. All right. So I'm going to take my first term in the first parenthesis, 3x, and multiply the 3 terms in the second parenthesis. So that 3x times 2x squared will give me 6x to the third. 3x times negative ax is negative 24x squared. 3x times positive 3 is positive 9x. All right, that's it for the 3x doing distribution. Now my negative 2 do a distribution. Negative 2 times 2x squared is negative 4x squared. Oops, sorry. Negative 2 times negative ax is, I like to be the same color. What was that? Negative 4x squared. Negative 2 times negative ax is positive 16x. And negative 2 times positive 3 is negative 6. Combine like terms. 6x to the third got no like term to combine back there. So still 6x to the third. Negative 24x squared minus 4 more x squared is negative 28x squared. 9x plus 16x is positive 25x. And my last term, negative 6. Okay, so that's my polynomial answer. All right, so we'll just quickly review your spatial product and multiplying of polynomials. Thank you for watching.